Hello, good morning friends. Welcome back to your favorite channel Code One Digest. Today in this tutorial I am going to cover classes in TypeScript. This is chapter 6 and in this chapter we will cover how to define class, how to write a class, how to define the member of a class and how to create object of the class, how inheritance works in TypeScript. So stay tuned and watch this tutorial till end. It is going to be very exciting and very informative tutorial today. Friends, in the previous tutorial, I covered functions and typecasting in TypeScript. If you want to learn what is function, how to write function, how to typecasting in TypeScript, so go and watch the previous video. If you have not seen the previous video, go and watch the previous video. The link is given on your screen and also given in the description section of this tutorial. Okay, friends. And I have also created a complete playlist of TypeScript where I have all the tutorial, all the chapters, all the lessons. I'll be explaining each and every concept in detail over there. So go and watch the complete playlist. It is going to be very useful if you want to learn TypeScript. Okay. Okay, friends. So here is the agenda of this tutorial. Today I am going to cover class, and in that we'll see how to define member variable. How can we control the visibility of those member variable? What is parameter properties? How can we define read-only properties in class? Then we see inheritance concept of implement. That means we'll see how to implement an interface. And then we'll also see extending a class. So we'll see inheritance extend by extending a class. We'll also see how can we override functions, and we'll also see a concept of abstract classes. So stay tuned and watch this tutorial till end. It is going to be very informative and exciting tutorial today. Friends, before we proceed in this video, I request you to subscribe this channel to grow Code One Digest family. Friends, I am creating a lot of quality videos on programming, coding concepts, design pattern and design principles, cloud and container technologies, but I'm not getting subscribers. I request you to like, share and subscribe this channel so that I can grow our Code One Digest family. Thank you. Okay friends, so now I have opened my Visual Studio Code, and if you can see here, I have created a new lesson 6. Okay, so inside that lesson 6 I have created one file classes.ts. The concept of class is very similar to what we have seen in Java or C++, right? The object oriented concept of the class remains the same. Here we have to understand there are minor deviation. There are some changes in the syntax and semantics, how we define the class, how we define the member variable, how can we control their visibility. Most of the concepts are very similar to Java and C++. So let's see how it works, how the classes works in TypeScript. Okay, member types. So member can be a properties or functions or methods in the classes. So let's see with some examples. So very first exercise, let's say I have defined a class person and name is the member variable of type string, right? The way we define variable, same way we define variable inside this class, name and string. When the modifier is not given here, so by default it will be public. We'll see that in coming exercise. Right now at line number 9, I'm creating an object, an instance of class person. If you see, the syntax is very similar to Java, right? We use a new operator in Java. Here also we use a new operator. So we are creating an instance of person. This person is now instance of class person. Now here I'm setting person.name is equals to Pawan, and at line number 11 I am printing console.log person.name. So here it will print my name. So this is first exercise, very simple. I just explain how you define the class and how to create object of that class, how to assign the value to that member variable, and how to print the value of that object, right? Clear? Now let's understand the member visibility. Class member also have given the special modifier which affects the visibility. There are three main visibility modifier in TypeScript: public, private and protected. These are very similar to what we have in Java, right? In Java also we have public, that means default, allow access to this class member from anywhere. Okay. What is private modifier? Only allow access to the class member within the class. Protected, allow access to the class member from itself and any classes that inherits it. The same class can access those variable as well as the subclasses who are inheriting that class can also access those variables. Right friends? Clear? Let's see that with example. Exercise 2, where I'm defining a class employee and having a private property here. We define private, name of the attribute, private name, and its type is string, right? So this syntax you are already familiar. The property name and data type, it will precede with the modifier that is private. Here we define a constructor with the keyword constructor. Okay, if you remember in Java, we define constructor with the same name as class, but here we have to use this keyword constructor. Okay, so public constructor, and in that constructor we are initializing the value of name. It takes name as an input, name string, and then it is setting that name into the member variable of employee class. Now I have defined another method to get this name because this is a private variable, right? I cannot access this name outside directly through from an object. Hence, I have to define a member function which can return me this variable name. So get name is string, it will return a string, and I am returning this dot name. Now at line number 38, I am creating a object of this class employee is equals to new employee and passing the name Pawan. If you see, the constructor expects a argument, one argument. If I don't give this, it will cry. It will not be happy, right? It will say it accepts one argument. Hence, I have to give the employee name in a constructor. I have given name Pawan. So this employee is having that name Pawan, and I'm printing at line number 39 console.log employee.get name. So this is very similar to Java, the concept of classes. Now there is a third concept of parameter properties. So this is interesting. TypeScript provide a convenient way to define class member in the constructor. So we can define the class member in a constructor itself. So far we have defined the class member separately here like this outside constructor. But in this concept, we will see how to define a class member in a constructor. So I have defined a class student and having a constructor here, public constructor, and this is how we define the variable private name string and just empty body. So what is the meaning of this? It is actually combining two statements. One is defining the member variable. I can also write like this, and then initializing that with this dot name is equals to name. Okay, I have combined these two statements and it become like this. Should not have any body and it should not have this statement, right? So we call it parameter properties and we do that only in the constructor. Okay, and then as this is defined as a private, then again I have defined a public method to access that name like previous example. Now at line number 54, I'm initializing an object of class student, okay, where I'm passing Pawan as the argument because it expects the argument. This constructor expects the argument, and this Pawan will get assigned to the member variable name of student. And then here I am printing the student.getName. It will print Pawan again. So this will also print the Pawan, right? Now we'll see how to define variable as a read-only variable. Okay, if you want to define any variable, member variable as a read-only, that means once it is initialized, then the value cannot change. Okay, similar to array, the read-only keyword can prevent the class member from being changed. Okay, so here I'm defining the member variable name. I have written public read-only. So read only is a keyword here, okay, and it is of type string. Public is a modifier, read only is a keyword, name is the name of the property, that is member variable, and string is a data type of that variable. Now in constructor, I am initializing that name right at line number 65, and I have also written a get name method to get that member variable. Now at line number 73, I am defining an object of animal class. Animal object is equals to new animal, and I'm passing the value as cat. Okay, so now animal object is having a having value as a cat. I'm printing that name here. Now what I'm trying to do at line number 75 is I'm trying to modify the value of member variable name. Okay, I can do that logically. I can do that at line number 75 because the name is a public member variable. So hence I am trying to assign a new value to the member variable name, but it is not letting me. Why? Because it's a read only. If you see this cannot assign the name because it is a read only property. It's very similar to final that we defined in Java, right? So once you initialize, then the value cannot change. Hence, I cannot change the value of name of this in this object because it is already initialized with value cat. Let me comment this because this will give me compile error. And then I'm printing again the name. So this should print cat and this should also print cat. Right, friends? Now let's see inheritance. What all different types of inheritance we have in TypeScript. The way we have interface in Java, we also have interface in TypeScript. We define the interface, shape, and member function. Get area, number. Okay. So get area is a function that is defined. It should return a value as number. Now I've defined a class rectangle that is implementing the shape interface, and then I'm forced to implement this method get area. Hence I'm implementing that method here, public get area number, and I'm defining the parameter properties here in constructor, width and height as number, and then in area method, this is my implementation of that function, this dot width multiplied by this dot height to calculate the area. I have another method get parameter, so this method will use later in following example. So here I am calculating the area by implementing the interface method. And at line number 99, I am creating an instance of rectangle by passing width as 5 and height as 3. So I'm printing here rectangle dot get area and rectangle dot get parameter. So it should print 15 here and it should print 16 here, right? Now let's see another flavor of inheritance using extend when one class extends the other class. So taking the same example, rectangle is a class, and now here class square is extending the class rectangle, right? Now here in constructor, this constructor, the constructor of class square is taking only single argument instead of two argument in rectangle. Okay, so in constructor of square, we are just taking the width because all sides are equal. And then I'm calling the constructor of superclass. So it will call the constructor of superclass by passing width into width and width into height. Okay, we'll see this override example in a while. Get area is a public method, hence it will also be available in the child classes. So now at line number 117, I'm creating a instance of a square class by passing 5 as a width, and I'm calling a square dot get area, though this get area is defined as rectangle class in a superclass of square and it is accessible. So it should print 25 and parameter it should print 20. Okay. Now another concept of inheritance is overriding. So if you see here I have defined a method in rectangle get parameter, and here it has a different formula to calculate parameter. That means the summation of twice of width and twice of height gives me the parameter. Now the formula changes for square, hence I'm overriding that method with the keyword override. So it's the same signature public get parameter, we just having a override as a keyword, and the formula changes this dot width into 4. Right friends? So this is how we can override the methods. Now let's see next exercise of abstract class. The concept of abstract class is very similar to what we have in Java. The way it works in Java, it works exactly same way in TypeScript. Okay, what is abstract class? Abstract class is a class where we cannot create an instance of that class directly, but we can create a child class of those classes. So here I have defined abstract class polygon having a abstract method get parameter which is returning a number. Now I've defined a class pentagon extending the abstract class polygon, and in constructor I am defining the parameter property of side, okay, private side number, and then I am implementing the abstract method here get perimeter number, and this is the formula of calculating the parameter of pentagon. So now what I'm doing is at line number 139 I'm creating an instance of pentagon, okay, by passing 6, and so at line number 40 I'm printing the console.log pentagon.get perimeter. So this method will print 5 into 6, that is 30 as the output. Right friends? We can try creating instance of polygon. Let's say constant polygon is equals to new polygon. What it says. Let's see. Cannot create an instance of abstract class, right? So the concept wise, it is very similar to Java. The TypeScript follows the same concept of object-oriented programming. It just the syntax and semantics are little different than Java and C++. Right, friends? Okay, friends. So now what I'll do is I'll run this code and show you the output of this class. Okay, let me go to the console. Okay, so I'm in my lesson 6 folder already. Let me type tsc class.ts, right? Let me run this. So it will compile the class and it will create the JavaScript file for me. Yes, it is done. Now I'll write node classes.js, right? So we'll see the output now. So see, it is printing pawan, 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 cat, cat, and then 15, 16, 25, 20, 30, right? The way we have defined the output in our code, 30, 20, 16, 15, cat, cat, pawan, and so on, right? So you can validate. So you can run the code and play with it. Okay, friends? So if you like this video, give it a thumbs up. And if you're new to the channel, so do subscribe to my channel to grow Code One Judges family. Friends, you need not to worry about the code. You can download the code from my GitHub repository and play with it. So here is the project, TypeScript complete tutorial inside Code One Digest Git repository. Okay, you can clone this repository. It has all the chapters, lesson 1, lesson 2, lesson 3, 4, 5, 6, right? It has all the exercises what we discussed in this tutorial and in all previous tutorial. So you can download this code, just set up into your Visual Studio Code and start playing with it. You need not to start from scratch, right? All the exercises, all the lessons are available in this GitHub repository. Okay, friends? Friends, if you like this video, so give it a thumbs up and subscribe to this channel for the more interesting videos. Click on the bell icon for the latest video notifications, and do not forget to share this video with all your friends and colleagues. This is very useful information for students, beginners, and software engineers. I am putting a lot of efforts in creating these contents. So please help me growing the Code One Digest family. Please subscribe to Code One Digest channel for the latest programming and technology related videos. Thank you.